and welcoming Mr. Williams Chirinos.
Yes. So, good evening, ladies and gentlemen. Today, I'm going to present an effective and integrated project management execution plan. This methodology was developed after more than 6 years of research at INEXERTUS. So, let's get started. This is the table of content. First, I'm going to talk about project management fact, the work opportunities, practices, and training behind that fact. Then I'm going to explain the integrated planning and execution methodology, which focuses on the planning phase. We will see the result-based technique, project work planning, baseline. And in the execution phase of projects, we will talk about earn value, earn scale, and performance measurement. At the end, I will illustrate the benefits of implementing this approach. But first, I would like you to think about this. According to your experience, what do you think is the percentage of successful projects in general? Taking into consideration that a successful project is the one that is delivered on time, with a final actual cost on or below budget, and in full compliance with the technical and regulatory requirements. So, let's say that that percentage is less than 50%. Raise your hand that if you think that that percentage is less than 50%. Right? Yeah? Most of you are right. 2 out of 3 projects experiencing difficulties meeting the 3 successful criteria: deliver on time, with a final actual cost on or below budget, and in full compliance with the technical and regulatory requirements. I brought 3 examples. The first one is the Standish Group report in 2009. They said that 32% of IT projects were successful, according to a survey that they did. Recently, Scott Ambler did some surveys in 2013 and published the result in 2014. And he said that those IT projects that applied agile methodology were successful in 62%, 2 out of 3. This is a good news for the IT industry. The second example is Ed Merrill. Ed Merrill said here at the Professional Development Conference in 2011 that 1 out of 3 mega projects has reasonable acceptable results. They studied around 300 mega projects worldwide, energy projects, chemical, mineral and metals, oil and gas. And for oil and gas, in particular, 1 out of 5 projects are successful. This is interesting for the oil and gas industry. And the third example is the AACE published a technical article written by Robert Walden in 2012. And he studied 28 Canadian energy projects, basically gas plants and oil sands plants. And half of them overspent $5 billion. The original budget was $16 billion, and the final actual cost was $21 billion. And more than half of them experienced scale issues. Now, why do projects fail? This is what our research is telling us so far. Those are the major reasons. First, there is an ineffective scope definition. And this is the starting point. This is what we are going to deliver, what we are going to build. Then there is a weak stakeholder alignment between the project sponsor, project manager, project team, the final user, the public, the government. So, also, there is unrealistic stakeholder expectations about the duration of the project, the final budget, technical specifications, quality of requirement, training, responsibilities. So, last but not least, there is poor communication. Not everyone is on the same page, from the start to the end of the project. Now, let's take a closer look of those 28 Canadian projects. If we plot the percentage of cost overrun and schedule slippage as a function of the total installed cost, the size of the project, we see that the larger the project, the greater the variances in cost and scale. We, as a project people, we need to reverse that trend. That's not good for the business, specifically in these times. We have to do something about it. We have to do something different in the way that we handle projects nowadays. Albert Einstein said that the best definition of insanity is doing the same thing over and over again and expecting different results. So, we have to do something about it to increase the probability of success and return of investment of your projects, our projects. We have to measure performance. We have to determine and keep track of the productivity index. Now, but what are the current practices behind that fact? Well, those are the things that we are studying so far. So, the work breakdown structure is the most powerful technique to define the scope of work of a project, and is primarily used worldwide. And there is still confusion if the work breakdown structure should be oriented by activities, method, department, procedures, or deliverables. Second, the planning steps, scope definition, schedule definition, and cost estimate are not always consistent. They usually are developed by different entities and in sequence. When the project goes into execution, usually the scope, the schedule, the cost estimate is not distributed within time. So during the execution, there are going to be changes. There are going to be changes in the project. We need to keep track of those changes. But usually, it's difficult to do that in 3 different documents. The common practice of activity task percent complete is not only an indirect method to determine physical project progress, but also incorporates objectivity. And I will give you an example. When you have a project with these all the activities and put them in a colorful schedule, then the team starts executing activity. You ask your project team, John, what is your percent complete in this activity this month? John may tell you, William, 40%. Next month, next reporting period, what is your percent complete in this? 50%. John says. And then, when the project reaches the final stages, you, as a project manager, start hearing percentages of 91, 91.5, 92, 92.5. Something that you know about, yeah? For sure. So, then, the comparison between the budget and actual cost is not sufficient to really know where we are, to really know what's happening in the field. I will give you an example. Let's suppose that we're going to build a road from A to B. The distance is 10 kilometers. We have a budget of 10 million, and we're going to build that road in 10 months. That's what I call the 10-10-10 project. So that means that we're going to build 1 kilometer of road every month, and we are going to spend 1 million. Three months after that, after the starting of the execution phase, we go to the site, say, okay, my plan value is 3 million. My actual cost is 3.1. We are doing well. But then you realize that they have built 2.5 kilometers of road. So the project is not doing so well. Why? Because budget is money in the bank. That's all. But value is assets. And the project is the transformation of that money in the bank into assets. Something that you can touch, something that you can see. And value. That's the value. Okay, and that's that project changes need to be handled proactively. Because we are going to face changes in the project. Projects are complex dynamics, and we need to find out those changes, approve the changes, and plan for the future work, if needed. It's interesting because currently there is an interesting trend in the way that we define projects during the planning phase. Miller and Norman, they said that the deliverables need to be a structure oriented by the work breakdown structure, needs to be oriented by deliverables. Miller says that only recently there has been a recognition that a better way to orient a project plan is by deliverables. And Norman said that the ability to manage the project at the detail level and roll out the deliverables based on the work breakdown structure hierarchy is a true power of the deliverable-based management. The PMI support those stages. And we, at INEXERTUS, we would like to go one step further. Not only support that, but go one step further. This is a step further. Involve the planning phase, work breakdown structure in the planning phase, and the earned value in the execution phase. Because those are the most powerful technique to define the scope and control the execution respectively, but are rarely used worldwide. What we did is taking the work breakdown structure one step further means that not only the deliverables need to be defined in the work breakdown structure, but also the events, because a result is either a deliverable or an event. And I'm going to explain this with a case study project. We will see some examples. And in the execution phase, we took the earned value technique, said, okay, we're going to apply earned value, but not in the traditional way, not using the equations that are in the literature. Instead, we use a simplified approach because we're working with project results. We'll explain that later in the case study. This made the planning and execution process easy and facilitated the communication because it's a good thing to have from the beginning of the project until the end the same information flowing in all levels with all the stakeholders. But we need to establish that as a project manager. Now, let's take a closer look of what is the result-based technique. Since deliverables are project products, for example, a technical report, a compressor, or an engineering package, and events are occurrences, something that happened. For example, the issuance of a purchase order, the sign off of a contract, or the process simulation plans that we need to feed the other disciplines to do their job. So, the result-based techniques consist on listing all these discrete results at the lowest level of each work breakdown structure branch. And we know that below this level, we have what? We have the activity levels. The activities. Because to produce a deliverable or to achieve an event, we need to execute 2 or 3 activities. But we don't go there. In this approach, we don't go to the level of activities. We stay at a higher level to give us a better overview of the project. And also why? Because that's what we discussed in the project review meetings. He said, did you finish the report? Did we sign off a contract? Did the compressor arrive to site? Those are the questions that we're talking about. I tell you what, during our project review meeting, regular project review meeting. And this is the engineering part. It's art and science at the same time. Who should be doing this? This needs to be done at the beginning of the project. Once you have a project, you need to sit down, depending on the size and complexity of the project. These planning steps may last 1 week, 2 weeks, 3 weeks, depending on that. And who should be doing that? The project manager should be the driver force to have this defined in the project. The project manager with the project team, project sponsor, suppliers, yes, vendors, yes. We need all those inputs because we need the project performers to tell us what is going on, what is going on to happen. Interesting without looking at activities. Let's take a look at an example. Let's suppose that we're going to design an engineering package, to work in an engineering package to build an oil and gas production facility. In a work breakdown structure, the ultimate deliverable, the final product, is placed at the first level of the work breakdown structure. Then, that ultimate deliverable is broken down. You need to break that deliverable into its major work components. In this case, project management, regulatory, engineering, and procurement. And you see that also engineering was broken down further into 3 sub-work components: design specification, drafting, detailed design. And here are the list of deliverables and events. Don't forget the events, because that's what the technique of result consists of. Consists of focusing on discrete results instead of activities and tasks. Again, I would like you to think about that a little bit, because usually when we talk to people, with our project team, hey, how's it going? How things going? I'm busy, I'm so busy, I'm really busy, I'm really busy. But remember, project is not being busy. It is about doing productive work. It's about using our deliverables and achieving our events, the one that is important for the project. Now, this is the complete planning phase. I would like to show you in 2 steps, but on top, you see that we define the scope with a work breakdown structure, DBM, work document, a scope document, etc., and a scale, and a process. Now, raise your hand if you use this. This is a common practice in your organization. Raise your hand. Interesting. Most of you. Well, one of the first differences between our approach to current practices is that we promote the integrated planning. And not only the planning, but also the execution. But let's talk about the planning. This is the entire planning phase. Defining a work breakdown structure based on project results, working at a higher level than the activity levels. Then, working with developing a project work plan, which is kind of a scale. And then determine the baseline, which is the cost estimate, is the budget once it's approved. Let's take a look of the entire, this is the simulation of the planning phase. In the top left, you have the work breakdown structure, the same work breakdown structure that we developed for our case study, the engineering package. On top right, you see the work plan, and at the bottom, you see the performance measurement baseline. The plan value curve, the S curve, or simply the baseline is the same. Now, The work plan is developed grouping the deliverables and events in control accounts. These are the control accounts. In this case, we have 5 control accounts. Now, the specification is drafting and design and procurement. And then, we distribute all the deliverables and events within time, according to when we are going to finish those results. But these need to be consistent with the resources available to produce those results, in order to have a realistic work plan. Resources, labor, material, equipment, subcontract, and other costs that you may think of. Then, the addition of that cost gives us the best one. This is an iterative process. You go back and forth from the work program structure, the work plan, best time, determine the resources, change dates from events, deliverable, etc., until you get an agreement between the entire project team, an agreement between all the stakeholders, specifically the one that are going to produce those results. It's very, very important. Then you freeze the baseline, publish the baseline, and the project is ready to start execution. But before going into the execution phase, I would like to talk a little bit more about control accounts and value. So the control account is important because that's the pockets where you add deliverables events with the corresponding deadlines and budgets. How do we group them? We may group them by homogeneous work. It's about engineering. It's all about construction, fabrication. Type of deliverable. It's all about coding for a program, or computer program, or it's all about survey. We may group them by geographic area, or we may group them by the accounting system in place. Why? Because the accounting system in place connects the project, the control account, connect the project with the accounting system in place. And we need that connection because during the execution phase, you're going to get the actual cost from the accounting system or invoices. You need to get that actual cost. It's the third variable in the value. So how many control accounts should we have in projects? Well, that depends on the size and complexity. But our simulation, the simulation of project that we have worked so far, is telling us that for small projects, 10 control accounts are sufficient. For medium projects, with a total installed cost between 1 million and 100 million, 10 to 20 control accounts work well. For large projects, between 100 million and 1 million, total installed cost, around 50 control accounts are sufficient. But this is a general rule. We can have projects with 100 control accounts, 150 control accounts. And for large projects, mega projects, it's good to break down those projects into larger and medium to be handled with this method.
So you're talking about it as a project, but what if it were a program with multiple projects underneath it?
The program, the methodology will be applied to projects right now. This is one.
So it's not focused on programs?
It's not focused on programs yet, the way that we are handling this. In the future, we will get it back. And we will do other dimensions. We are focusing in 3 major, the main dimensions of project: scope, schedule, and cost. But we are not, we don't forget about quality, risk management. All those variables will be incorporated in our methodology within time. Good question. So the plan value, as I told you, this is our work plan. This project is going to be executed in 6 reporting periods. But this project lasts 1 year, which means that each reporting period is equivalent to 2 months. And if we expand the second month, we see that in this month there are 3 control accounts active: plan, specification, and drafting. And these are the resources that I need to produce those results: cost control progress report, data sheet, and discipline scopes, and flow diagram. I would like to point out here that it's important to have a good granularity with this methodology, because that will depend on the control. But it's a scale issue. Why? Because if I want to control this project monthly, I will have 12 reporting periods. And if I would like to control this project bi-weekly, I will have 24 reporting periods. In this case, I just showing you 6 for practical reasons. Now, we are going into the execution phase. We have a plan. We are going to simulate the execution phase. Error value is the most powerful technique and use 3 variables, as you know. Plan value is the one that we just determined. The error value is the monetary value credited for the physical work accomplished, and the actual cost is the track record of action. Now, these 3 variables are cumulative, because each time that we close a reporting period, we need to do error value analysis based on previous performance. That's what we have in the project: previous performance, cumulative. And then forecast the final cost of the project if current trends continues, and forecast the completion date. It's interesting because the final cost, we can get that with the error value calculation. But to forecast the completion date of the project, we need to incorporate error schedule. Error schedule was presented by Wally, and it complements the error value theory, because error schedule takes a look of the time dimension. Error value is work-based, error schedule is time-based. With this, with error schedule, we can determine the schedule time earned based on the physical work accomplished, equivalent to the error value that we just accomplished. That's interesting. Now, what is the simplified approach that we apply in this methodology? We are not using credit error value, we are not using fixed formula, weighted milestone, percent of completion of activities, that's the most suggested one, or level of effort. We are not using those techniques. Instead, we are using the binary completion theory, which states that something is either done or not done. This is the third difference with this methodology current practice.
This is a work plan that we developed for our 6 reporting periods bi-monthly, and we have here the plan value per month and the cumulative plan value, or our S-curve. The error value and cumulative error value, which is our green performance curve, and the actual cost per month and cumulative, which is our red line cost in our performance curve. And here below you have the error value calculations, the error value analysis. We have the variances, indices, and forecast for the total project, and for the error schedule, and for each control account. So in the first month, a project is on a schedule because we deliver what we said that we are going to deliver that first 2 months. It's slightly over budget because the actual cost is a little bit higher than the error value. And the project is a result, 6% complete. It's a number that is over there. It's based on what's happening, what we are delivering. Let's go to the second reporting period. A couple of deliverables behind. So the project is slightly behind schedule. It continues slightly over budget, and we start seeing the separation here between the error value, physical progress, with our plan value, and also the actual cost. The project is slightly over budget, the difference between the red and green, and the project is 16% complete, an output of the methodology. With this variance, error schedule is telling us that the project will be completed 2 months behind schedule. The third reporting period 2 months each reporting period. In the third reporting period, we complete the behind deliverables, a milestone. And we have something behind here, in red. The project continues behind schedule and over budget. 31% complete, but the end schedule is telling me that it's going to be 1 month behind the schedule. In the fourth reporting period, we see now that we catch up with the deliverables that were behind. There are some deliverables pending. The project continues behind schedule and a little bit over budget, 47% complete, 1 month. We project that we're going to finish 1 month behind schedule. When we close the reporting period number 5, we see a little bit more difference between the earned value and plan value curve and the earned value and actual cost curve. We see that behavior, and this is more or less the same. Behind schedule, over budget, 68% complete. Will be delivered 1 month after. Now, when I execute the last reporting period, I see that still I have a couple of things pending that move to the next reporting period, number 7. But this is the time where the earned value should have been equal to the plan value to close the project, and 1-1. But the schedule is telling me, oh no, you will finish also 1 month behind, and the project is currently 94% complete. And finally, I finish the project, and I see the closing between the earned value and plan value, and the actual cost is independent. The project closed 3.8% over budget, is 100% complete, and finished 1 month behind schedule. So the most important thing here is, this is a simulation. We can simulate many projects, specifically for the past to learn. And projects are dynamic things. If we have a major change in the scope of work of the project, this curve may change. We may do a reverse line at the reporting period number 4 and stop that plan value here and generate a new plan value that will begin in the earned value point. Is where my reverse line is going to start. That's an interesting point for you to keep in mind. To finish, I would like to state the benefits of this methodology. First, we keep all the stakeholders focused on the most important thing. Generate the agreed results. Because project is to generate result. We are more realistic estimating resources because we are working with a baseline and we are working with an integrated planning. That's the key. If you work with an integrated planning that will be also consistent with the changes that we want to happen in the execution, we have something different to work with. We credit progress only for the event achieved and deliverables completed. So this gives us maximum objectivity. We want facts as a project people. And since we are applying earned value, we have the opportunity to continuously measure, forecast, and report physical project progress, to take action in those control accounts that experience more variance, and to manage by exception the project. Focus on those control accounts that has more variances. And then, because the final objective of this, as a project people, is that we need to increase the probability of success and return of investment of our project. And we need to do something a little bit different, just a little bit. But let's take one step at a time. Thank you very much.